Hello, everyone. Welcome to another edition of Business Calculus. This is the video lecture for Business Calculus Math 1325, Section 11.5, Absolute Min and Max. So there is a difference between absolute min and max and relative min and max. Honestly, this is a pretty short section. I'm looking through my notes here, and it's just a little bit of like gotcha moments once in a while, but well, you've come to expect that at this point in this class. Please don't blame me. I'm not the cause of it. So, what does it mean to be absolute, right? The absolute means it's the very highest or the very lowest. So the very highest, or that's a terrible or the very lowest. So let's do some examples. Let's say that I had like a parabola that does this. This would be an absolute minimum because there's nothing down below it at all, okay? But what if you had like a cubic that kept going forever? These guys are still mins and maxes, but this is called a relative max, and this is called a relative minimum. The reason why is because this keeps going down forever, so I do have something lower than that. And same thing with the max. I got this going up forever, so it's a maximum because it's a neighborhood. It's the highest. It's on a hilltop, but Mount Everest is right here, and it keeps going forever. So what we're going to be doing is looking for, the mins and maxes, basically like f prime. Let me try that again. F prime is equal to 0, solve for x. I mean, that's basically what our formula is. But we're supposed to also be testing the endpoints. And what does it mean by endpoints, right? So just as an example, let's say I had that cubic. Let's try that again. Okay. But then it stops. Imagine that there's no arrows. So it just stops. So what we're going to do is test these endpoints along with f prime here, and to see if we have the absolute highest. So this one would be the absolute maximum, and this would be the absolute minimum in this particular case. But what if I did this? Watch this fun stuff here, okay? What if I did this? That's perfect. That's perfect. So we're still testing our derivatives, okay? But the highest is actually going to be this one. That's the absolute max. And this one here is the absolute min. Basically, I cannot tell you if I have the highest or the lowest point until I test my derivative and the endpoints. I have to do both and just basically read them all out and see which one's the best, okay? That's my goal. Now that we got that, let's just jump right into some problems. So 511 or 11.511, it says find the absolute min and max on the interval 1 to 12. So the absolute min and max on the interval 1 to 12. Notice that these are bracketed, the square brace. The brackets mean that I'm including those 2 points, which means I have to like test those points. They also give you a graph that like part of the question in a way, and it looks kind of like this. Something like that. And I have this is at 1, and then this guy is at 5, and then 12 is like right here actually, like as in like x equals 12, by the way. I should probably clarify here, okay? So this right here is at 5. I don't know where this is. I think it's like, I'm looking here. Let's just call it 10. I don't really know. I don't have that because, well, it's not an answer. Let's call that 12, okay? So these are the points on the graph. They give you this right here. And they say find the absolute mins and maxes and that kind of thing. So this one is the easiest. You can just look at them, and you can see that this one here is the minimum, and this is the maximum. And so part A says the absolute minimum is blank at x equals blank. Okay, now here we go again. Part B, absolute maximum is blank at x equals blank. Okay, so what do they mean by all this? Basically, these are the y values, which I'll show you here in a second. The minimum right here is definitely 1, and the maximum is at 5. So we can at least say that much. That's pretty easy. As far as where the graph goes, you're going to have to look at the graph, and essentially this right here is at a height of 8 for some reason. There you go, it's 8. I don't know. You just look at the graph, find out how high it is. There you go. And this one's obviously at 0. So then I'm going to say the minimum is at 0. My absolute max is at 8. Again, these are my y values. This is y equals. They're not going to say that, okay? But I'm telling you, it's y equals. All right. It really is not too bad. Just look at the graph. So, f of x is equal to x squared minus 6x minus 5 on the interval of 0 to 5. And they say find the absolute min and max yet again. So the absolute min and max. Because they don't actually have a graph, we could find a graph. I'm actually going to refrain myself a little bit here because I like using Desmos. You know me, I'm a Desmos fan. And yay, look at that, we got something. But 0 to 5, it doesn't really show that stuff. So let me just give a little bit more. If I plug in x equals 0 and x equals 5, then I guess I could find the intersection points, and those are going to be my three important points that I need to test. And you can already see which one's the highest and the lowest. This is not hard. But let's just say I'm actually going to do calculus for once because I get bored and I actually want to do some calculus because it's fun. So we take a derivative, and I'm going to set it equal to 0, and solve for x. It's a 3. Yay. So this is a min or a max. I don't really know yet, but it's an important point. And so basically I'm going to use the 0, the 5, and the 3, and I'm going to test them in the original and see which one is the highest and which is the lowest. Okay. Now, to do this faster, I'm going to use some Desmos Scientific if you don't mind, but really I'm just wanting to test each one. So x equals 0, I have a negative 5. This is how you normally do it, okay? If you're going to be a good student, then this is how you're supposed to be doing it. If I'm a good teacher, this is the method in order to get this thing done. Okay. Now I'm looking at all my numbers, and I want to know where's the highest and the lowest. And this one here is the highest. I know it's negative, but it is the highest. And this is the lowest. And so the highest is going to be my maximum, and my lowest is going to be the minimum, as in like the absolute min and max. And so there you go. Like I don't know how to say this. That's your answer. But if you go back, you already saw that here, didn't you? See that? It's right there and right there. You already saw those two, okay? Cool. But we did a little bit of calculus. It made it fun, right? So let's move on to the next one. So 11, 5, 51. So this one's definitely different. I have f of x is equal to 10 minus 2x minus 8 over x on the interval of 0 to infinity. And they say find the absolute min and max. And now notice that the 0 is not included, so I can't plug in 0. But really they're just trying to restrict the domain to the positive side of things, and that's really what they're trying to say here, okay? Again, I'm tempted to go and use Desmos, but honestly, I just want to do it. I want to be good. I don't want to be good, but I do want to do it. So if you wanted to see what this is technically this guy. So I'm going to bring that power down to make it a positive 8 over, and then, hold on. And then it's going to be a negative 2 power, which puts it in the bottom. And I'm going to set this equal to 0. How I'm going to do is I'm going to move the 2 over. It's got 8 over x squared is equal to 2. And then I'm going to move both of these back and forth, like switch them around. That's a 4. Square root. So you get plus or minus 2. And this is my potential points. Now the thing is oh, I have a note here to myself. So I want to like plug them in. I want to say like, you know, f of 2, f of negative 2. I guess I should have put negative 2 up there. But I can't plug in the endpoints. Like basically I want to also say f of 0, but I can't do that. And I want to say f of infinity, and I definitely can't do that. So I'm kind of stuck just plugging in his 2 points and hope for the best. You're going to be so disappointed. I have to use Desmos graphing. Just kind of like look at what's going on here. We could have done a lot more investigating. But here we go. Oh, no. I could have done it. Never mind. I was looking ahead. I thought that I had a whole other problem, but I guess my notes were all a little weird. Okay. So here's your graph. And there's your 2. So yeah, I really should have done this. Now, negatives wouldn't have counted because I'm only looking for the positive. And so I'm going to plug in 2 into my original. So 10 minus 2 times 2 minus 8 over 2. So that's a 4 and a 4. That makes 8. So 10 minus 8 is 2. So it's just a 2 comma 2. And that's going to be my absolute maximum. So absolute max is at 2 comma 2. But there's no minimum. There's no minimum for us. If you look at the graph, it's just the maximum. They keep going down forever. All right. But hey, Chad, if you zoom out, you see the other end. Oh, there's a minimum right there. And it's at that negative 2. But I already said that it was disqualified because we're only looking at the positive end of things. We're only looking at the positive. So that's your answer. Yeah. Okay, well, I did use Desmos, but I didn't have to. I was just kind of confused about my notes. It looked like, what am I doing to myself? And yeah, it was just me going to the graph again. That's fine. Okay, so I'm not good. I mean, if you can use Desmos graphing, just go ahead and do it. You know what I mean? It's honestly a really big help, especially when they're asking these kind of questions. The interval is 0 to infinity, yet again, and they want the absolute min and max. Okay, so let's do this thing. Without a calculator. Yes, I'm going to not do a calculator at all. No way. Get rid of that thing. It's gone. Ugh. So I want the derivative, and I'm going to set it equal to 0. Low d high minus high d low divided by the square of what's below. So low d high, derivative of e to the x is e to the x. High d low, that would be a 5x to the 4, divided by the square of what's below. So now that's going to be a 10 power in the bottom, essentially. So I got x to the 5th e to the x, and then I have 5x to the 4th e to the x, all over x to the 10. You can see that I can cancel some x's out, leaving x e to the x minus 5 e to the x all over x to the 6. And they have e to the x I can factor out like this. All right, so there's my derivative, and I'm saying, hey, this whole thing equals 0. And that means the top is equal to 0. And so I got e to the x is equal to 0, and that does not work. But I got x minus 5 is equal to 0, and that's easy. X equals 5. Cool. So that's one of my important points. I would also say 0 is interesting because it's a vertical asymptote from the bottom, 0. So watch out for that kind of stuff. But then again, it did say my interval was only positive things. So I'm going to ignore that. I'm just going to say 5 is positive. So we're good. We're going to use it. And it's probably the only answer. So I'm going to plug in f of 5 because I have nothing else to plug in. Oh, it's e to the x, right? So yeah, that's e to the 5 over 5 to the 5. Right? Is there really? I guess so. All right. Here we go. E to the 5 divided by 5 to the 5. Looking at my answer. Yeah. Yeah, that's what I got. Now, they don't like so many decimals for some reason, so they're going to round it to this guy. And there you go. This is going to be my absolute, what? Is this a minimum or maximum, right? Well, then again, I have to go to the graph to absolutely know for sure. But I guess I could also test around it to see if I got other things. Nah, it's better just to graph it. See, I can't get away with it, man. I said, no, I'm not going to do it this time. And you look, I did it, okay? I did it. Home. So I don't need the negative. We're only looking here, and there's your 5, and there's your answer. And we could have just looked at it, minimum. Oh my gosh. Can I just say I'm not going to do calculus anymore? I'm just going to look at the graph. I guess. I don't know. There you go. There's your answer. Absolute minimum. Okay, this is the last one I got here in this section. Obviously, you can see that it's not too bad of a section. And if I saw something like terrible, I would do it. Like this one. This one has 6 parts. Yay! But I don't. It's not too long, honestly. So here we go. I'm not going to vow to do anything or not to do anything because obviously the graphing part is super awesome and it helps a lot. And at minimum, it just at minimum, it at least speeds it up a lot. So here, step 1, graph it. Home. That's not really handy. Oh, okay. Well, there you go. It's not perfect, but let me just kind of do a rough graph of what I'm expecting here. It looks kind of like it's like this, and then it kind of does this, and then it goes back up. Okay, that's kind of what I'm thinking. So I can just click on them. Boink, boink. I know they're kind of hard to see, but there and there. Okay. Now they're going to play tricks with you. Okay, so I found my min and max, but there's also some other things. So they're going to play tricks with you. Here we go. Part A, they're going to say, look between -2 and 10. -2 and 10. What I want to do is I want to look at what, yeah, I'm basically going to be around in that zone anyways. So let me do my x values so you can see a little bit better. Let's do -10 all the way to 15 for now. And let me just see what that looks like. Okay, that looks not too bad. Let me do some more y value. I'm going to do like -1000 to 1000. Okay. Okay, that's legit. That works. Okay. So what they're wanting to do is find out these values here. And so I'm going to do f of -2 and find it. I'm going to find f, and I've already found these other points, right? Let me just remind you of these guys here. We had 3, so this was x equals 3, and this is x equals 7. So 3, I'm going to test 3 out. F of 7, I'm going to test that out, and then we're going to also test the 10. Notice that, again, I'm testing the f prime equals 0 stuff, my mins and maxes, but also the endpoints. I'm going to come back to the graph. The graph will do it all for you, but let me just be, I don't know, a little bit slow for just a second. So, one by one, I got a -372. I want to put an equal sign for each one of these. Let's see what else I got. I got a +178. I got a +114. And I got a +276. So this one here is the smallest, so that would be my minimum. And this one's the biggest, so that would be my maximum. And there we go. So those are the answers. Yay. Now, could I have done that on Desmos graphing? And yes, x equals -2, x equals +10. And then you can click on where the intersection points are. And here's your other ones here. So those are the 4 important points. I'm going to ask you which ones have a y value that's the biggest or smallest. Smallest y value, biggest y value. We're done. So you can just use Desmos graphing for it all. All right, they say, hey, do it again, but only from 2 to 7. And so notice that basically this is going to be wiped from the last one, and we're only testing these guys here now. I think that this one's a little easier. So I'm looking to say, what is the highest point from only these three? Because it just so happened that 7 was also one of my critical points. So this one's the minimum once again, and this one is the maximum now. So that's what I would say. Again, how you're putting all these in, like let's just do it for this one. It'll say the absolute minimum is at blank, and it'll say x equals blank. And so then you're going to say -2, -372. And then the absolute maximum, same kind of thing, okay? So last one, it says, hey, this time we're only going to look from 5 to 10, including 10, by the way. So I'm going to use those points. 7 is still legit, and then 10. But now I can't use the 3 because 3 would be outside of that zone. So 5 to 10, like basically between these two lines. So right here, right there, and right there. Those are the only 3 that work. And so let me write those down just in case. So at 5, 146, 7, 114, and then I got the 276. So this is my smallest, and this is my largest. Copy paste. Okay. Cool. That was it. That's all I got there. So, thank you very much. Have a great day.